Here's a video on factoring two-term polynomials, binomials. So there's two types that we will see. The first is a difference of two squares, a DAS problem. And the second could be a sum or a difference of two cubes. So both of them follow a pattern, and a lot of it is just memorization. We will learn how we can use polynomial long division to do the sum or difference of cubes. But for difference of two squares, there's two things you need to look for. You have two perfect squares, so 36x squared and 49 are both perfect squares. And then you have a minus in the middle. This only works if there's a minus in the middle. And so the pattern is, if I have two perfect squares, the result will be the square root of the first term plus the square root of the second, and then square root of the first term minus the square root of the second. So if I have 36x squared minus 49, I know this is the same as 6x quantity squared minus 7 quantity squared. And so I can just follow this pattern. This will factor to 6x plus 7, 6x minus 7, and we are done. Again, it doesn't matter where the plus or the minus are, but you need one plus, one minus. So the second example is a higher order one, but we can follow the same process. X to the fourth is a difference of squares. Minus 16 is a difference of squares. We have two perfect squares, x to the fourth, 16, and we have a minus in the middle. So I will have, if I want to break it down, so we have x squared quantity squared and minus 4 quantity squared. So I would have x squared minus 4, x squared plus 4. But as we've been going through, you always want to check to see if you can factor more. And if I look at x squared minus 4, this itself is a difference of two squares again. And so my final answer, x minus 2, x plus 2, x squared plus 4. There's my final answer, factored form for x to the fourth minus 16. Now, sum and difference of cubes is a different rule. You can do it for a plus or you can do it for a minus. Instead of looking for perfect squares, you're going to look for perfect cubes. And this pattern ends up being f minus L times the quantity f squared plus FL plus L squared. So there's a little mnemonic device to help remember the order. SOAP means same sign, opposite, always positive. So this sign here will always match the original problem. This sign will always be the opposite of the original problem, and this sign will always be positive. So when we look at 27x cubed minus 8, I first need to figure out, well, what did I cube to get 27x cubed? And that would be 3x. What did I cube to get 8? That would be 2. So I'm just going to follow this pattern. So my first binomial would be 3x minus 2. Now I'm going to square it. Opposite sign, so this is a minus, opposite is plus. I'm going to multiply these two together, and now I'm going to square, which is always positive. Again, it's just a pattern that we have to know. So same, opposite, always positive. For a sum of cube, same rules, same sign, opposite, always positive. So what did we cube to get 8x cubed? That's 2x. What did we cube to get 125? That's a 5. And so my factored form would be 2x plus 5, same sign, square the first term, opposite sign, multiply, square with a plus. And so that's the factored form. 8x cubed plus 125 is equal to 2x plus 5 times the quantity 4x squared minus 10x plus 25. The resulting trinomial will never be factorable.